In this video, we want to solve this problem, and I'll be explaining telescoping sum by solving this problem. After that, we'll be solving similar problem, AIME 2 2014 problem 7. And for this problem, related ideas are these: telescoping sum product and rationalization and hints are these two things. Okay. So for this part, I consider 1 over root k equals 2 over 2 root k. Why we do this? Because then we can write 2 over root k plus root k. Now, because we have 2 root k's, we can use inequality. We can say 2 over here. Root what plus root what? And here it's greater than 2 over root what plus root what. Okay, if we decrease denominator because they are positive k's, at least one, the fraction will be increased. So let's decrease here k minus 1 and k. For this one, it will be k and k plus 1. Okay. Now we can write here what? If we rationalize, then we should use this identity that a squared minus b squared is a minus b times a plus b. So here we can multiply this part by root k minus root k minus 1 over root k minus root k minus 1. So the denominator will be what? Will be root k squared by this identity. Minus root k minus 1 squared will be k minus 1 will be 1. So it will be 2 times root k minus root k minus 1. Okay. Now what about left hand side? If we do the same thing exactly, we can say it will be 2 times root k plus 1 minus root k. It is less than what? Less than 1 over root k here that we had, less than 2 times root k minus root k minus 1. Now let's consider k from 1 to 80 and see which sides can be proved. Okay, if we consider k1, it will be 1 over root 1 is less than 2 times root 1. We replace k with 1 minus root 0 greater than 2 root 2 minus root 1. 1 over root 2 is less than 2 times root 2 minus root 1 greater than 2 root k with 2 3 minus root 2. Okay, let's keep writing. 1 over root 3 will be less than 2 times root 3 minus root 2 if we replace k with 3 here. And on this side, it will be 2 times root 4 minus root 3. Let's write all of them up to 1 over root 80. Last one here. Less than 2 times root 80 minus root 79 if we replace k with 80, greater than 2 times root 81 minus root 80. Okay, now telescoping sum here, we have also telescoping product similar to this. Is exactly this part. When you add all these inequalities, left hand side, these terms will be cancelled like this and this. So also here we can say this part will be cancelled, this part will be cancelled, this part. So if we call this value equals a is greater than what? 2 times root 81 minus root 1. So let me write like this. 2 times root 81 minus root 1 less than a, greater than 0 is 0, 2 times root 80. Okay. I want to prove what? I want to prove it is greater than 16, less than 17. Okay? If we consider 81, root 81 is 9. Root 1 is 1, 9 minus 1, 8. 2 times 8, 16. 16 is less than 8, 2 root 80. If, so we proved first side. This part is left. If we can prove a is less than this, the problem will be, so a less than 17. So if this one is less than 17, this part will be solved. Let's check this one. If we raise both sides to the power of 2, it will be 4 times 80, which will be 320. This part 17,289. This one 320, so we will see it doesn't work. Okay. Now we should do something. For this part, we should write here instead of first part because it is 2 here. We should write it is equal to, let me write with other color. It is equal to 1. Okay, and from here, let's cancel. So if we consider now, if we add all these things, again, 1 equality and all of them less than. So if you add, it will be less than. A will be less than 1. 2 times negative 1 minus 2 plus 2 root 80. So it will be 2 root 80 minus 1. Okay. Now I want to prove that it is less than 70. Okay, so let's prove this part. If we prove this, then this part will be proved. So let me erase this part. We can say here what? This one we can add 1 to both sides. So 2 root 80 y is less than negative 1, 7, 18. And if we raise the power of 2, because both sides are positive, we can do that. 4 times 80 y it is less than 18 squared, which is 324. 4 times 80 is 320, and this part is correct. So this is correct, this is correct, our sentence is correct. So we proved this problem. Now let's solve a similar problem. So let's solve this problem of AIME 2, problem 7. Again, related ideas, telescoping rule, logarithm rules, hint here. I will add some hints. And so let's try this problem. F of x is this. We want to find the sum of all positive integers, and for which we have this equation. So when absolute value of something is 1, the thing inside is plus or minus 1. So we can say sigma k1 to n log f of n, f of k to the base 10 is plus minus 1. Now we have one rule. Log a to the base b plus log c to the base b is log ac to the base b. Okay, so if we expand this sigma, it will be what? Log f of 1 to the base 10 plus log f of 2 to the base 10 to log f of n to the base 10 equals plus minus 1. Now if we apply this idea here, then it will be log. We can change this sum to product inside log, like this rule. AC here. Log f of 1 times f of 2 to f of n to the base 10 equals plus minus 1. By the definition of logarithm, if log a to the base b is n, then a is b to the n, like this. Okay, so here we can conclude f of 1 times f of 2 to f of n is 10 to the plus minus 1. Okay, so 10 to the 1 is 10, 10 to the negative 1 is 1 over 10. Now let's focus on f of x. We can say f of x is x plus 1, x plus 2. We can factorize cos pi x. If we consider x and cos pi x, for x1 it is cos pi negative 1, for x2 cos 2 pi 1, for 3 negative 1, for 4 1. So it's important that n is here, x is odd or even. So f of x is what here? If we factorize this, it will be x plus 1 times x plus 2 to the power of cos pi x. It is 1 or negative 1 in odd numbers, odd x's. It's negative 1 in even x's, it is 1. Okay, so let's write f1 to fn. We want to see it is what? f1 times f2 times fn. So the first one, f of 1 is 1 plus 1, 2 times 3. Cos pi is negative 1, so it will be 1 over 2 times 3 when n is 1. Times, next one, f of 2, 2 plus 1, 3 times 4. 3 times 4 for n2, cos pi times 2, which is 1. Then times 1 over 4 times 5 for n3. It will be 1 over 4 times 5 times 5 by 6 times 1 over 6 by 7 times 7 by 8 times 1 over 8 times 9. So let's see what happens. N4 here, N5, so here, N6 this one, N7 this one, and so on. So I want to find general form. If n is odd, it will be what? Look for some n1, 1 over 2 times 3. If we consider this part, this will be cancelled, this will be cancelled. 1 over 2 times 5. So first one, 1 over 2 times 3, next one, 1 over 2 times 1, 5, next one, 1 over 2 times 7. So if we check, it will be 1 over 2 times n plus 2. Because for 1, it is 3, for 3, it is 5, for 5, it is 7. And if n is even, what happens? So let's see this part, even. 3, 3, 4 over 2 for n2. For n4, you cancel this, 6 over 2. So it will be n plus 2 over 2. Okay? Now we want to see hence that this value is 10 or negative 1 over 10. This one can only be 1 over 10. It cannot be 10 because n is positive integer. This one can be 10. If we simplify this case, if we multiply by 2, it will be 5. So if we cross multiply, n plus 2 is 5. If we subtract 2 from both sides, n is 3. Next one, we multiply both sides by 2, n plus 2 is 20. So if you subtract 2 from both sides, n is 18. So second value, it says sum of all positive values of n. Answer is 3 plus 18 is 21. Okay. If you wanted to solve more problems, you can check my website. And if you had any question, you can feel free to send message. My WhatsApp number in the description. Thanks for watching this video. Have a good day. Bye.